In this section, we want to know how to use the calculator in order to come up with a p-value for a hypothesis test for a proportion. So the function that we would use is under the stat menu. So you press the stat key, come over to the tests submenu. So just slide over to that submenu, and if you scroll down just a little bit, for me it's the 5th option, but it might be different for you. One prop z test, that's the function that we want to use. So the 1 stands for a single proportion, so we're not comparing the difference between two. Prop, of course, stands for proportion, similar to a percentage. Z notes that we're using the normal distribution to calculate the probabilities. And then test says that we're working for a hypothesis test. So we'll go into that function, and it requires a certain number of input values here. Now, the input values that we need are going to be p sub 0, and that's going to be the percentage that is, or the proportion, however you want to state that, that's mentioned in the null hypothesis, so it would be claim about the population. Okay, x is going to be the number of items that favor your event in a sample. N is the number of items total in your sample. And then this option here, prop not equal to p0, less than p0, greater than p0, this tells the calculator what type of test it's going to use, and that's either a two-tailed test, a left-tailed test, or a right-tailed test. And ultimately that decision is just made by the symbol that's used in the alternative hypothesis. So let's assume we have some statement about a population which says that 87% of something qualifies. So that's the statement about the claim. All right, so 0.87. And then suppose we have a sample size of 825 items, of which 747 qualify for this event, whatever it happens to be. So then you have to decide, based off of your alternative hypothesis, what type of test you're working with. Then let's just use a two-tailed test. We could use any of them, but only depends on the context of your problem when that matters. So we'll leave it as two-tailed and hit calculate. The output that it gives first is a z-score, so a test statistic, in this case 3.028. Then p, that's your p-value. So that's what you're looking for, most hypothesis tests. So in this case, 0.0025 if we round to 4 decimals, but just follow the rounding rules in your problem. P hat, so this is literally if you take the value of x that you input and divide that by n, your sample size, that gives you the percentage out of your sample. That's what p hat is. And then n, of course, is your sample size that you input previously. But that's how the function works, and the values that you generally need would either be one of z or p, or sometimes both.